Everyone across the world is talking about Model Context Protocols, known as MCP. But very few people understand why this might be the most important invention for AI agents in the last 3 years. The internet is a web of communication held together by sets of rules and conventions known as protocols. Without these protocols, the internet as we know it just wouldn't exist, and that is what MCP might just become for AI. AI agents are seen as the future of technology, but a major question has still not been answered. How do we connect agents to the real world in a universally accepted way? These are similar challenges and questions that those in the 1980s had to work through to make the internet universally accepted and adopted. In today's episode, I'll explain exactly why protocols are so important when building technology ecosystems around the world. I'll explain in simple language what MCP means, and finally why it's so important for the future of AI agents. I think I'm going to start off with explaining a little bit why protocols are so interesting and important, because really it speaks to the importance of rules and frameworks that many different people all over the world can kind of subscribe to build technology systems that become more powerful over time. Because a lot of the time, when we see amazing new things come out every year, every month, every day, it sometimes feels like it's easy to think that innovation just happens. You know, I'm sure people have seen HTTP : when you kind of search for something in a web browser, and you'll often notice that HTTPS or even that lock icon when you search for something. And this was the HTTP protocol revolution that literally laid the foundations of the modern internet. Again, I'm putting this into context of the MCP, so the Model Context Protocol. Because Tim Berners-Lee, so basically the creator of the internet, he introduced this HTTP, which is Hypertext Transfer Protocol, around the late 1980s. And it was a very simple approach to fetch HTML documents, or documents that can be displayed in a web browser. And again, it doesn't seem massively exciting and cool or sexy, but that protocol unified everyone all over the world who were building technology around this straightforward method of delivering web pages to users who wanted to search for things. It literally was laying the foundations of the internet that we know and love today. And these frameworks become even more important when something's completely new. It's easy to forget that right now there's no accepted way of doing something within AI. You know, we're all building, innovating, and as a result, there can be many different approaches taken, which sometimes makes it very difficult to kind of collaborate, integrate into each other. And so these protocols make it really easy for all these separate, disparate people to come together over a single approach to building technology. And again, coming back to that HTTP, which essentially enabled a web browser to fetch a HTML document. So again, how we all experience content online now. And we can tell an identical story with email. Before we had a standard, when you sent an email, they typically stayed, say, within a single local network. So all these computers connected to each other via wires, or even a single machine. And that would be wonderful if you only need to talk to people in the same building. But in the 1980s, a man called John Postel formalized that new framework and protocol, so SMTP, which basically gave everyone around the world suddenly a uniform way to send emails across different servers. So this was the key to that explosion in email reaching the mainstream. So all this is to say that protocols are so damn important to enabling the builders, the innovators like maybe Mindset and many others, all the way to the IBMs to kind of create something that everyone in the world can use. So if you ever reflect and wonder at how these incredible things like the internet is built over time and how it's scaled to so much complexity in people, some of the most important parts to that happening was these open standards and protocols that everybody in the world can implement when building technology. So how does this relate to large language models and AI agents? Well, before this protocol, there's been a real big bottleneck for AI agents becoming super successful and globally adopted. So I'll take you back a couple of years to help you understand why this is important. Now, to explain this bottleneck, I'm going to take you back to when ChatGPT came about. So around 2022, LLMs, large language models, made this incredible launch into the mainstream. And tools like ChatGPT obviously started generating very coherent paragraphs or summarizing text, writing code, answering Q&A. And obviously by probably 2023, the public hype around ChatGPT was at like an all-time high. And suddenly anyone with access to the internet has this super powerful AI system. But many companies such as Mindset and others obviously wanted to connect these to the rest of our physical and digital worlds. You could ask it an incredibly complex question, what's the basics, or give me an explanation of quantum physics. But if you said book a flight next Thursday, it would never be able to do that. And that's a lot of the time because it has no standard method to, say, talk to a flight booking API on a company's website, or maybe read your email or check your calendar. And this is where function calling came in. So function calling let developers build a system which allowed a large language model to call a tool, so maybe an integration. So a human can be having a conversation with, say, a chatbot, and that chatbot is able to, through function calling, call through to an integration to do something. Before MCP, so Model Context Protocol, the way that this would work is a developer or product team might see a user need, so might want to search the web. So a developer would need to write an internet search tool and essentially hook that into a search API, maybe Microsoft or Google, whatever it might be. And then the user might then want to connect that to Slack. So the developer would have to then write a Slack integration. And now the user might want to connect to a database. So you then have to write another integration to another database. So you get the idea. It's a lot of ad hoc implementations and integrations. So if you have 15 types of tools, you need to do 15 separate integrations or programs. And if that external service changes, so the search API or Slack's integration or whatever system you integrated into, suddenly things can all go wrong again. And similarly, if an LLM changes, so maybe OpenAI runs a big update into its model, that can also have a negative impact on the ability for you to use tools. So a really good example here is we've been experimenting for a long time with using different large language models. So swapping between Google's, Meta's, OpenAI's. And when we say switch from GPT to, say, Claude, so by Anthropic, or to Meta, so Llama, the way an agent would work with different tools would suddenly be completely different. And things wouldn't work the exact same, just because of the way that LLM interpreted certain instructions. Again, that's completely unscalable. It's kind of reminiscent of the early internet before these amazing accepted protocols came into being. And so now enter Model Context Protocol. So what is MCP in very just simple terms? Well, you probably got the gist so far. It's an emerging standard that hopes to unify how an AI model or agent or product with agents interacts with an external system. So maybe instead of writing those custom integrations each time, you can give the model access to a single layer, so the MCP layer. And then through that, it can communicate with a number of tools or databases or whatever it might be. So if you picture this, there's 3 columns. So you might have a company like Mindset who makes it easy to build, manage, and deploy AI agents with large language models connected to them. Then in the middle, you have that MCP, so the Model Context Protocol. And this is a standardized protocol that translates AI requests into something that a service can understand. So if I wanted to integrate our agents into Google Sheets or Google Slides or whatever it might be, as long as Google has that MCP layer working, it makes it really easy for us to do that. And no matter what changes get brought in by Google in the future or another language model, it stays secure. And then in the third column, you have that external service, so a database, Slack, Google, whatever you want to integrate AI into. So that means all these different services, so that third column, like a Slack or a Google, essentially will have what's called an MCP server, which is basically a fancy name for software that speaks the language of MCP. And that means that companies like us, Mindset, can very easily integrate into the Googles, the Slacks, the whatever we want to integrate into. So this basically unifies the language. So the AI can say, fetch the user data from Google Spreadsheet. And that MCP server for the Google Spreadsheet knows exactly what to do. And it will return very consistent, structured outputs back to the AI consistently. Whereas right now, if Google makes an update or a large language model makes an update, those connections can very easily break or become inconsistent. So why do I think this is so important, and what does it, I guess, mean for everyone listening to this conversation? A recent paper on AI agent capability sums up why I think this is so important and exciting for the future of AI. So there's very obvious things. There's going to be fewer integration annoying headaches because it becomes very simple for everybody to integrate into, say, Google's MCP server to integrate into their apps. It's also going to be more reliable. Any updates or changes to, let's say, Google spreadsheets are not going to break any of the integrations because everyone follows that exact same standard and makes sure whatever they might launch works and complies with that MCP language. And the reason I'm most excited is that it has the potential, if it's accepted, to create an even bigger AI ecosystem and even faster growth in agent abilities. Because as I keep saying, the easier it is to start something, the cheaper it becomes, the more of that thing is spread across the economy and society and every single device in the world. So we're just going to see this network effect and explosion of more entrepreneurs, more innovators, more massive companies implementing AI in their current products. And that final point is critical because this is already moving really fast and it's only going to get faster and faster. And you've probably heard of Moore's Law, which predicted that computing power would double every couple of years. Well, a recent research report actually found that there might even be a Moore's Law for AI agents, with this trend showing agent capabilities doubling every 3 months. Researchers created a range of tasks for this experiment: coding challenges, reasoning puzzles, cybersecurity tests, and measured how long it would take for an expert programmer to do every single task versus how well the AI could do all of it on a single run. And then they essentially tracked the performance across several models released between, say, 2019 and now. And the result is absolutely shocking. In 2019, large language models could handle tasks equivalent to only a couple of seconds of human effort. In 2023, that leapt to tasks a human might spend up to 4 minutes on. And this year, that has gone to tasks taking around an hour. To put that in perspective, let's assume that an AI can handle tasks of up to an hour today. You might then do 1 or 2 doublings, and it can suddenly handle tasks that would require humans multiple hours of work. Another few doublings, and it can take multi-day tasks. And this is where real disruption can start to happen. Now, there are criticisms of this research report. For example, some people complain that the research uses a 50% success rate threshold. So that means that the AI in the study only has to succeed on half of the tasks at a given difficulty level. And others have argued that these coding benchmarks or puzzle-like tasks don't really capture day-to-day complexities of human tasks. The fact that we're seeing real data indicating an exponential curve when it comes to AI agents is really interesting to me. Because if we come all the way back to model context protocols, this innovation is happening without any universal protocols that led to the internet exploding. So just imagine what happens when or if these types of protocols are adopted when it comes to AI. And obviously, if it achieves that broad adoption, things will move really, really fast. The likes of OpenAI and others may try to introduce competing protocols that benefits their long-term goals. Either way, as these things are created, AI agents are just going to become more useful and more powerful for companies like us to integrate into the systems that everybody uses on a daily basis. I will consistently bet on the fact that the cheaper and easier something becomes, the more people use it or build on top of it. So that's it for this week. Thank you for listening. If you know any friends, colleagues, maybe your pet dog that would love to listen to this episode, please do share it with them. Anyway, stay curious. I'll see you next week.